Since the dawn of time, we have always been fascinated with our night sky, always wondering about what lies ahead of that blanket sky, always wanting to know more about our universe. Our dreams to observe our universe led to many ground-based telescopes watching the stars. But we always want to know more, see more. So on the 7th of December 1968, the Orbiting Astronomical Observatory 2 was launched into orbit. Nicknamed Stargazer, the OAO-2 satellite was NASA's first successfully launched space telescope, after its predecessor, OAO-1, failed to operate after launch. The satellite remained in operation until February 13, 1973, when it was turned off after a fatal power failure of the WEP, the Wisconsin Experiment Package. The satellite consists of two data collecting instruments, one at each end. One of these instruments is the WEP, and the Smithsonian Astrophysical Observatory, the Celescope. The WEP consists of 7 different telescopes designed for ultraviolet observations. The instrument observed over 1,200 objects throughout its lifespan. The Celescope is made up of 4 telescopes that fed into UVicons, which is an ultraviolet light detector. The instrument observed 10% of the sky, resulting in a catalogue of 5,068 UV stars. Astronomer Mark Thompson will now be discussing the next generation of space telescope, the Hubble Space Telescope.
The Hubble Space Telescope is probably one of the most spectacular human endeavours to explore the universe. So one of the main, or two of the main problems with studying the night sky is first of all the atmosphere, because the atmosphere, which is a protective shell around the Earth, affects all of the light that's coming into us here on the Earth, which means any telescopes looking at the sky from here have to look through the atmosphere. That's a problem. And the weather, of course, is also a problem. So getting telescopes above the atmosphere is one of the most important things to give us the best chance to study the universe. So the Hubble Space Telescope was probably one of the most spectacular attempts. It wasn't the first space telescope, but one of the most spectacular attempts at getting telescopes up into space to get above that atmosphere. One of the most important instruments on the Hubble Space Telescope is actually called COSTAR. Now, when the telescope was launched back in the 90s, there was a major problem with the optics. Now, when the telescope was made, they made 2 mirrors, and one of the mirrors that was sent, or the mirror that was sent up in the telescope, was made. It was the most accurate mirror ever ground, but it was made to the wrong curve. So the result was that the images that came back from the telescope were hideous. They couldn't get a nice, sharp focus. So NASA had this wonderful idea of sending up a piece of equipment that would allow them to correct the problem with the optics, and without that, the telescope would never have been able to take any of the amazing images that it's taken. And essentially what they did is they had to sacrifice one of the instruments that was on board, and they replaced it with this thing called COSTAR, which is a corrective optics system, which all of the light from the telescope went through, and then that fixed the problem with the focus, and all of a sudden we had the universe revealed in all its glory. Now, the Hubble Space Telescope is probably the most revolutionary telescope because we've got an instrument that records optical light. It was the first main optical instrument to be put up in orbit. It also detects a little bit of infrared as well, so there's all the heat radiation. And it's also big. The whole thing is about the size of a double-decker bus. And with telescopes, it's important to have size of aperture, which means the main mirror that collects all the light has got to be as big as possible. And it's a bit like a funnel. So, if you stick a funnel out in the rain, you'll catch an awful lot more rain by going into the funnel than you would just trying to get rainwater in a little test tube. So a mirror for a telescope is like a great big funnel, and getting that telescope with this massive mirror up into space above the disturbance of the atmosphere meant that it was a real game changer for studying the universe. Okay, probably one of the most important scientific discoveries that's come from the Hubble Space Telescope is to fine-tune something called the Hubble constant. And the Hubble constant is it's a variable. Well, it's not a variable. It's supposed to be a constant, but it's actually one of the most variable constants in science. And using that constant, if we understood exactly the number of Hubble's constant, what that means is we can actually use the measurements of the distances to objects in the universe and the velocity that they're travelling to actually work out the age of the universe. And the Hubble Space Telescope has actually given us a great opportunity to fine-tune the Hubble constant an awful lot, which is what we're now doing with it. There have been hundreds and hundreds of discoveries made by the Hubble Space Telescope because we've had an optical instrument above the atmosphere, all of a sudden everything becomes so much clearer. It's a bit like people who've got eyesight issues suddenly getting a pair of glasses and all of a sudden they can see clearly. So putting the telescope up above the atmosphere has revealed a huge amount of detail on the atmospheres of the planets. It's revealed gas clouds around newly forming stars in the Orion Nebula, which is a big cloud of gas and dust that you can see in the constellation of Orion in the winter. And we can peer inside that with Hubble, and we can actually see disks of material around stars that are forming inside that cloud of gas and dust, which we believe is the precursor for solar systems forming. So there have been literally hundreds and hundreds of discoveries made by the Hubble Space Telescope.
Our understanding of our universe as we know it was completely expanded the day the James Webb Telescope came online. On the 25th of December 2021, the James Webb Telescope was launched into our Sun's orbit at the second Lagrange point. It took 6 months for the telescope to complete its journey, coming online on the 12th of July 2022, sending images down to Earth. The James Webb Telescope uses 2 different instruments to photograph distant stars and galaxies in both infrared and visible light. These instruments are the NIRCam, the Near Infrared Camera, and the MIRI, the Mid-Infrared Instrument. These cameras allow us to see galaxies 33 billion light years away, allowing us to see into the past at what our early galaxies looked like 250 million years ago, after the Big Bang. This is the SMACS 0723 galaxy cluster, one of the most detailed images of early galaxies to date. The James Webb Telescope allows us to see this cluster as it looked 4.6 billion years ago, a tiny sliver of a vast universe. We've come so far in a short amount of time. In just 53 years, we have discovered so much about the universe we inhabit. However, there is still so much of our universe we have left to discover, and with each new generation of telescope, we inch ever closer to our goal of understanding.